Hello everyone, welcome to the Engineering Geology and Hydrogeology course. This lesson, let's continue to study the texture and structure of igneous rocks and the common types of igneous rocks. First, let's learn the definitions of texture and structure. The texture of igneous rocks refers to the degree of crystallization of its constituent minerals, the size and shape of the crystals, and the manner in which crystals and the glassy material are interconnected. It is a comprehensive reflection of the physiochemical environment during magma cooling and solidification. It describes igneous rocks from a microscopic granular perspective. The structure of an igneous rock, on the other hand, refers to the characteristics exhibited by the spatial arrangement and the filling patterns of various mineral aggregates within the rock. Structural characteristics are determined by properties of the magma, the conditions of its emplacement, and the spatial movement state of material components during solidification process. It describes igneous rocks from a relatively macroscopic perspective, focusing on the arrangement of aggregates. This section is quite detailed, so it requires your careful attention and patience. Please study diligently and observe carefully. Textures of igneous rocks. Based on the absolute size of the crystal grains, textures can be divided into three types: phaneritic, aphanitic, and glassy textures. Phaneritic texture. These mineral grains in the rock are relatively large and visible to the naked eye, or with a magnifying glass. This is a texture typically found in deep intrusive rocks. Based on the grain size, it can be further subdivided into coarse-grained, medium-grained, fine-grained, and micro-grained textures. Among them, coarse-grained texture has a grain size of greater than or equal to 5 mm. Medium-grained texture has a grain size between 1 mm and 5 mm. Fine-grained texture has a grain size between 0.1 mm and 1 mm. Micro-grained texture has a grain size of less than 0.1 mm. These two images show granite with a phaneritic texture. The image on the right is magnified 20 times under a microscope. From the figure, we may see that the rock has a granular appearance visible to the naked eye. A phanitic texture. These mineral grains in the rock are very small and not visible to the naked eye or with a magnifying glass, but they are visible under a microscope. This is a common texture in hypabyssal and extrusive rocks. The picture shows rhyolite with an aphanitic texture. Glassy texture is composed of non-crystalline material. It is dense and glass-like. This is a common texture in extrusive rocks. The picture shows obsidian with a glassy texture. Rock textures. Based on the relative size of the crystal grains, it can be divided into equigranular and inequigranular textures. In an equigranular texture, all mineral grains are phaneritic, and the crystal grains of the same major mineral are roughly equal in size. Equigranular texture is relatively common in intrusive rocks. In the picture, the rock S mineral grains are visible to the naked eye. In an inequigranular texture, the crystal grains of the same major mineral are unequal in size, with a significant difference. The larger mineral crystals are called phenocrysts. The fine-grained, minute crystals, or aphanitic, glassy material are called the ground mass. When the ground mass is aphanitic or glassy, it is called a porphyritic texture. Similar to the spots on a Dalmatian, this texture is commonly found in plutonic or extrusive rocks. When the ground mass consists of minute crystals, it is called a subporphyritic texture. This is commonly found at the margins of plutonic rocks or in hypabyssal rocks. The texture of an igneous rock is studied from a microscopic perspective. This is one way we study igneous rocks. Next, we will study igneous rocks from a macroscopic perspective. We will continue by learning about the structures of igneous rocks. The structures of igneous rocks include massive, flow-banded, vesicular, and amygdaloidal structures. In a massive structure, mineral grains are uniformly distributed, with no preferred orientation. The rock forms a uniform, massive body, such as granite porphyry and andesite. Flow-banded structure, characterized by columnar and acicular minerals, elongated vesicles, and bands of different colors. They are arranged in a specific direction, forming a flow-like structure. It reflects the flow patterns of magma after erupting onto the surface. This is commonly found in acidic rocks, such as rhyolite. Vesicular structure, formed when magma erupts to the surface and cools rapidly, and gases and volatile substances within the magma escape, leaving behind circular, elliptical, or elongated cavities. Vesicles can occupy more than 70% of the total volume. This is commonly found in pumice or pumice stone. Amygdaloidal structure, formed when vesicles in extrusive rocks are later filled by secondary biomass that differ from the original rock, such as calcite, silicon dioxide, zeolites, or opals. This is commonly found in basalt and andesite. The above content covers the textural and structural features of igneous rocks too. So, what are the common igneous rocks that possess these textural and structural features? The table shows representative rocks for acidic, intermediate, basic, and ultra-basic categories. Next, we will introduce these 4 rock types one by one. First, acidic rocks are represented by rhyolite, granite, and granite porphyry. Rhyolite has an aphanitic texture and a flow-banded structure. Under the microscope, quartz and feldspar form flow lines. Granite porphyry has a subporphyritic texture and a massive structure. The phenocrysts are composed of orthoclase. Granite has a phaneritic granular texture and a massive structure. Its mineral composition includes feldspar, quartz, and biotite. Intermediate rocks are represented by andesite, diorite porphyry, and diorite. Andesite has a porphyritic texture and a massive structure. The phenocrysts are composed of plagioclase and amphibole. Diorite porphyry has a subporphyritic texture and a massive structure. The phenocrysts are composed of amphibole, and the ground mass is composed of fine-grained amphibole and plagioclase. Diorite has a phaneritic granular texture and a massive structure. Its minerals are composed of plagioclase and amphibole. Basic rocks are represented by basalt, diabase, and gabbro. Basalt has an aphanitic texture, vesicular structure. Diabase has an ophitic texture and a massive structure. The phenocrysts are composed of olivine and pyroxene. Gabbro has a phaneritic granular texture and a massive structure. Its minerals are composed of plagioclase and pyroxene. Ultra-basic rocks are represented by peridotite, pumice, and tuff. Peridotite has a phaneritic granular texture and a massive structure. Its minerals are composed of olivine. Pumice has an aphanitic texture and a vesicular structure. Tuff has a pyroclastic texture and a massive structure. Its composition includes lithic fragments, crystal fragments, and volcanic ash. In this lesson, we mainly studied the texture and structure of igneous rocks and the common types of igneous rocks. This concludes our study of igneous rocks. Next class, we will continue studying the sedimentary rocks among the 3 major rock types. See you in the next lesson.